We all know about and may have even seen a solar eclipse on Earth. A solar eclipse is a beautiful and spectacular phenomenon where our moon's orbit takes it directly between our viewpoint on Earth and the sun. The moon, purely coincidentally, is the right size and distance from us that its angular diameter is almost identical in size and shape to the angular diameter of the sun in our sky. This leaves for an impressive spectacle where the corona of the sun, or in other words, the sun's upper atmosphere, creates a ghostly aurora around the moon. The corona, normally too dim to see, extends for hundreds of thousands of kilometers into space. Looking closely around the edge of a total solar eclipse, and you'll also see the silhouette of the moon's craters along the outside, plus these reddish wisps coming off from the sun. These are prominences, millions of tons of charged particles suspended in the sun's atmosphere by powerful magnetic fields. But is the Earth the only place in the solar system to experience such eclipses? Where can eclipses be seen? Firstly, I'll explain some of the terminology to do with eclipses. A total solar eclipse is when an object moves in front of the sun, completely obscuring it. It's also known as an occultation of an object. This is the kind of eclipse we see on Earth when, at certain points in Earth's orbit, the orbit of the moon aligns with the sun. The moon casts a shadow on Earth about 250 kilometers in diameter, which moves across the Earth as the moon orbits. The sun will only be totally obscured within the diameter of this shadow. Outside of that, the sun is only partially obscured from the viewer's perspective. This viewer is witnessing an annular or a partial eclipse, also known as a transit. These terms occultation and transit will be important for later in the video. The shadow moves across the Earth extremely fast, at roughly 1 kilometer a second. Witnessed from a high altitude, it is a majestic sight as the shadow shifts across the landscape. Satellites have also witnessed the movement of this shadow. The shadow isn't as sharp as you might expect, and this is due to the size of the sun and the moon and their distance apart. The sun itself is huge, a whopping 1.4 million kilometers across. The moon is much smaller at only 3,400 kilometers across. Now, this image isn't to scale, but it shows visually why the shadow isn't sharp. The umbra is the shadow where the sun is completely obscured, and the penumbra is the shadow where the moon only partially obscures it. This part of the shadow is much wider than the 250 kilometer wide umbra shadow. So why doesn't the moon create eclipses every month when it orbits in front of the sun? Well, this is because the moon's orbit is not in line with Earth's orbit around the sun. This means there are only a couple of times per year when the alignment is just right. The alignment of 3 celestial objects is known as a syzygy. A very cool word, but not something you'll need to remember for this video. I just thought you would find that interesting. So now you know the mechanics of an eclipse, we can have a look at where other eclipses take place in our solar system. But firstly, we'll stick close to Earth, because it would make sense that if the moon can occult the Earth, then surely the Earth can occult the moon. And the answer is yes. But it's not the shadow that's really the visually appealing part of this, from Earth's perspective anyway. That is because the Earth is 4 times as big in the moon sky as the moon is on Earth. So when the Earth fully obscures the sun, the whole moon is in the umbra. At first, the shadow of the Earth creates a crescent shape, explain that, flat earthers. But what is different this way round is that, unlike the moon, the Earth has an atmosphere. This means that when the moon is totally eclipsed, the Earth's atmosphere refracts the sun's light around the planet, gently illuminating the moon in a reddish hue. This makes for a beautiful but almost spooky view. The color is caused by Rayleigh scattering, a topic I've discussed in another video. Rayleigh scattering is the same process that makes our sky blue and our sunsets red. This image is beautiful in that you can see the different wavelengths of light being scattered through the Earth's atmosphere, from deep red from this side through to blue on this side. From the moon's perspective, none of the sun would be visible during a total eclipse, but the atmosphere on the Earth would be illuminated, so you would see a ring around it. This is an actual view of a lunar eclipse on the moon by one of the Jackson probes in 2009. It is quite the awe-inspiring sight. The Earth and Moon aren't just getting in the way of each other either. Here is the Earth and the Apollo 12 spacecraft in 1969 while it was on its way back home. And here's the Moon getting in the way of Earth from the perspective of the Discover satellite. Interestingly, this is the side of the Moon you never see, as the Moon is tightly locked to the Earth, which means the same face is always looking towards Earth. From this perspective, the Moon looks very foreign, but it is indeed a real video of our only natural satellite transit in the Earth. From another satellite's perspective, but this time looking at the Sun with the SDO satellite, the Moon often makes an appearance. This satellite, unlike Discover, orbits around the Earth, which means the Moon can block the Sun occasionally. And here's the Moon again, this time from the perspective of the stereo satellites. And the Moon isn't the only thing that orbits between us and the Sun. Mercury often transits across the Sun, a tiny minnow compared to the solar system's giant. The next time this will happen is on the 11th of November, 2019. So if you get an opportunity, take a look. Otherwise, you'll have to wait until 2032. Venus also orbits between us and the Sun. And as it is much closer to us and bigger than Mercury, its silhouette appears much larger. Its last transit was in 2004 and 2012, but sadly, if you miss those two, chances are you will never see it. These transits happen in pairs, and then there is a 100-year gap until the next one. In other words, the next transit will be in 2117. This happens for the same reason the Moon doesn't eclipse us every month. The orbits just don't often align. Still, we have high-definition videos of the last one, and it is still quite the sight to behold. Moving to another planet now, we can go to Mars, which has plenty of unmanned robotics, either in orbit or on the surface. Mars has only two moons, Phobos and Deimos. They are both pretty small. Phobos is 22 kilometers across, and Deimos is only 13 kilometers across. They both orbit very close to the planet though. Phobos is only 9,000 kilometers above the surface, and Deimos is only 23,000 kilometers. Which means although tiny, you can still easily see them from the surface of Mars, especially Phobos. The Curiosity rover was able to capture a moment where, incredibly, Phobos eclipsed Deimos. This video is captured in real time and shows the size differences of the moons in the Martian sky. And this is not all Curiosity rover captured. It was also able to see a transit of Phobos in front of the Sun. Due to the distance of Phobos to Mars, it moves across the sky fairly quickly, only taking about 7 hours to orbit once. This means that this video you're watching is in real time, and these solar eclipses on Mars don't last for more than about 30 seconds. The surrounding ground does get noticeably darker during an eclipse by Phobos, and can be seen from the rover's perspective. But it can also be seen from space. Phobos' shadow here can be seen by the Viking 1 orbiter, and also here more recently by the Mars Global Surveyor. The Opportunity and Spirit rovers have also seen a transit of Deimos, but it appears much smaller, just a dot passing in front of the Sun. It doesn't cause a noticeable decrease in brightness. Mars is pretty impressive, but that's not all the solar system has to offer. Have a look at this video captured by the Hubble Space Telescope looking at Jupiter. Jupiter has 4 large moons, 3 of which, at certain points, can transit the planet at the same time, leaving 3 big shadows. The moons in question in this video are Io, Callisto, and Europa. Interestingly, like we talked about before with the Umbra and the Penumbra, you can see that because Io is the closest to the planet, its shadow is the sharpest, whereas you can see with Callisto, the furthest away of these 3 moons, the penumbra is much larger, causing a blurry shadow. And in this video, Hubble spies the occultation of Ganymede, the largest moon of Jupiter. Cassini saw some incredible transits and occultations of Saturn's many moons. Here is one of Epimetheus passing in front of Titan, with Dione coming in from the side. This little white dot coming in from the left just under the ring is in fact only a bright background star. And this humble view is magnificent. Here are Enceladus, Mimas, Dione, and Tethys orbiting Saturn. Once every 15 years, Saturn's rings or moons are aligned just right, so that the moon's shadows stream across the rings as well as on the planet. This video is a time-lapse that lasted about 9.5 hours. It's amazing. Going a bit further out, we come to Neptune and its biggest moon, Triton. Sadly, we don't have a video, but this image, captured by Voyager 2, is gorgeous. 3 days after passing by Neptune, Voyager was able to capture the crescent of Neptune and Triton, before Neptune slipped in front of Voyager's view of Triton. Going further out again, we come to the furthest celestial object explored in our solar system, Pluto. As New Horizons whizzed by Pluto in 2015, it turned its camera back towards Pluto to capture the dwarf planet totally eclipsing the sun. What it saw was dazzling. The sunlight streams through and illuminates the atmosphere in its haze layers, with the ridges and mountains on Pluto's surface highlighted by the stark contrast of Pluto's night side.